Good morning, all of you. In the last class, we have finished this dynamic lift first part, that is lift on aircraft wing. Now, in that second one, blowing off roofs by Windstorm. So, how the roof will go off due to this windstorms? See here, let us suppose this is a house. Okay, and this is what door. Okay, see here. Now, when this wind is blowing, this is what the wind velocity, and due to this wind, the velocity is more here. Yes, and that's why due to this velocity, whatever the pressure is getting applied here, this is what, let us assume that pressure P, and whatever inside the house pressure you are getting, that is what, let us suppose P naught. As velocity of blowing wind is more above the roof, so that's why P is more above the roof, that is P is less, and therefore P is less than P naught. Yes, P is less than P naught. So due to the pressure difference, roof is lifted up, and is then blown off, due to or by the wind or wind. Okay, Okay, understood? Yes. So above you have more velocity, that's why less pressure. Inside house you have more pressure, and that's why due to this pressure difference, roof is lifted up and is then blown up by the wind. Okay, so note down fast. Or else will you note down later? Anyhow, I'm going to upload. Okay, let's move ahead. Now, next one. Attraction between two parallel and closely moving boats. Okay, so what happens here? When two boats move side by side in the same direction, then water in the region between them moves faster than that on the remote sides. So due to this, what happens? The pressure difference is getting created. Yes. So pressure between the boats is less, and due to the high pressure outside, they are pushed towards each other. Okay. So if I want to draw the diagram for this, let us assume that these are the two boats. Yes. Like this. And they will come closer. Yes, because pressure is more here. Here also P is more. Here in between pressure is less. That's why they will move towards one another. Okay. Yes, this is also one, we can say, application of this dynamic lift only, right? Next one is Magnus effect. Okay, what is the Magnus effect? You will get 2 marks question in IP exam on this Magnus effect. What is this Magnus effect? When a spinning ball is thrown, it gets deviated from its mean path. From its main path. Or we can say usual path, anything. This in cricket Those who are playing the cricket, they know this. Even in tennis also. Yes, no? In flight. Yes, this effect is called Magnus effect. Okay. Now see, assume that ball is, yes. Now let's assume that the ball is here. You can see is a ball, and now wind is blowing something like this. Now see here, this is what the velocity difference you are getting. The ball spins due to this velocity difference. When we will see here above, you will have more velocity. You will have v plus vr, and down you have v minus vr as the direction is reverse. So at the top of the ball, above the ball, what we will get? More velocity. Yes, no? Above the ball, v is equal, means v of the ball is equal to what? Or just velocity I am writing here. Above the ball you have v plus vr, and below the ball you have v minus vr. More velocity, less pressure. Yes, no? And that's why p is less. Here it is p is more, and due to this it gets deviated from its mean path. Okay, so that's why p at bottom below is greater than p above the ball, and due to this pressure difference the ball will deviate from its mean path, where this vr is equal to r omega. You can substitute this. Okay, so this is what the Magnus effect. Okay, note down this letter. So let's move ahead. Next one, that is viscosity. Okay, this is next topic, viscosity. Now you know, usually you might have observed that the honey is there and water is there. Okay, so water will flow, even honey will also flow, but honey will have little bit more friction in between the layers. Yes, no? and that's why honey is more viscous as compared with water. So what is this viscosity? First of all, let's see. Okay, see here, the property of a fluid, a property of fluid due to which it opposes the relative motion, due to which it opposes the relative motion between its adjacent layers is called viscosity. Okay, the property of fluid due to which it opposes the relative motion between its adjacent layers is called viscosity. Okay, that is a fluid friction or internal friction. Fluid friction or internal friction. Yes, no, between the two layers. Cohesive forces we can say. Yes, no. So due to the cohesive forces, this is what viscosity. And if suppose you want what is viscous force, you see here, the force between the layers opposing, the force between the layers opposing the relative motion is known as the viscous force. Okay, yes, and here you can write for your understanding, honey is more viscous than the water. Yes, okay. And what is the cause of this viscosity? Cause of viscosity, if somebody will ask you, what you will say? Yes, cohesive forces between the molecules of adjacent layer. Okay, this is what the cause of the viscosity, and due to this cohesive force the velocity will decrease. Yes, no? Got it? Understood? Right? Okay, let's move ahead. Now, next one, coefficient of viscosity. Yes. So now for this, what we have to do, we will assume that the liquid is flowing over horizontal surface. Okay. Assume that this is what the horizontal surface, and now liquid is moving above it. So you will have different velocities as you are moving upward and upward. Yes. If suppose this distance between these two layers is delta x, okay, and this velocity, suppose if this is v, then this one will be v plus delta v. Yes, no? So as you are going up and up, the velocity of liquid will be more. Yes, clear? So I am considering these 2 points or these 2 layers, that is p and q. So for the q you have velocity v, and for p you have v plus delta v. Yes. Now these 2 layers p and q separated by distance delta x, and velocity at p is v plus delta v, velocity of q layer is v. Okay. Now relative velocity between the layers delta v is equal to, or just I am writing delta v only, relative velocity is delta v only, no? Yes, relative velocity between the layers is delta v, Now this delta v divided by delta x is called velocity gradient. What is this? Velocity gradient, where delta x is what? The distance between the 2 layers, and this delta v is relative velocity. Okay. Yes. Now the above one Above layer is moving very fast. Yes, this one as compared with down one. Yes, no. So according to Newton's viscous force, or according to Newton, viscous force is directly proportional is directly proportional directly proportional to number A, area of the layer, and number 2, the velocity gradient. The velocity gradient. And that's why this force, that is viscous force, is direct proportional to A, and also this force is direct proportional to what we can say minus delta V by delta X. Now, why this minus sign I will mention below. So if we will remove this proportionality sign, F is equal to minus eta into A into delta V by delta X. This is what viscous force formula. Okay. And what is this minus sign indicates? So minus sign indicates viscous force on a fluid, viscous force on a fluid acts in direction opposite to the relative velocity of fluid, to the relative velocity of flow of fluid. Yes, no. Obviously, because this viscous force is only the responsible one who will decrease the velocity, and that's why it is acting in opposite direction to the fluid flow. It is same like friction only. Yes, no. Always friction acts in the opposite direction to the motion. Same thing here also. This viscous force always acts in opposite direction to the fluid flow. Okay, got it. Clear? Okay, understood. Okay, so let's move ahead. Now see here. Now let's see how actually the flow is and what happens. Now these are the, what we can say, in between what fluid is flowing. So what I am doing, you see, now this one is L, okay, and this point is E, this one is F. This is what fluid flow direction, and this is suppose velocity V, okay. Right. Now this one is what, delta X. So initially liquid has shape A B C D, okay, no, yes, right, and after or in time interval, due to, let us take delta T, what happens, this shape will change, shape changes like A E F C, okay, A E F C. So now here, as this shape changes, can I write like this, shear strain? Shear strain is equal to what? Delta X divided by L. We know this already, we have learned in shear strain. If this is angle, this by this. Yes, no, delta X by L. Okay. And now this strain rate, what I want, strain rate is equal to what, rate? Delta X divided by L divided by delta T. Yes, right now. Okay.
Okay, sir.
And that's why you have, this is equal to delta X by L into delta T. Is what? Strain rate. And what is the coefficient of viscosity? That is what I am going to tell you now. What is the coefficient of viscosity? So see here. The coefficient of viscosity. The coefficient of viscosity. And we are denoting it with eta. What is this coefficient of viscosity? Eta. Okay. And see here now. It is, how to define it? It is the ratio. It is the ratio of shearing stress. Ratio of shearing stress to the strain rate. To the strain rate. And therefore eta is equal to F by A is shearing stress, and this delta X by L into delta T is what your coefficient of viscosity. Yes, no? Right? Now, how I can modify? If this velocity is equal to this L by delta T, we can write. Then what we will get? You just see. Or this delta X by delta T, if I will represent as a let us suppose mu, because mu is velocity gradient, no? Yes, no? Velocity gradient. In the first page, I think we have seen delta V by delta X we have. Here we have delta X by delta T, right? So let's do it with mu. Is it okay? Okay, we will denote this. This is delta X by delta T. Yes, no? Delta X by delta T is what? This is not velocity gradient, okay? Delta X by delta T we will denote it as a mu, okay? Then what happens? Let's see. If mu is equal to delta X by delta T, then eta is equal to F. This A will go down. F by mu into A, and this is L. Okay, where this mu is what? Delta X by delta T. Okay. So what we can say it as a delta X by delta T. Yes. We can say the change in dimensions per unit time, we can say yes, no, or change in whatever the displacement is there, lateral displacement in time. It is like velocity dimensions only. Yes. So within how much time this is going to change with respect to time? That is what delta x by delta t. That is mu. If we have substituted, then FL by mu into A. Yes. Got it. Clear. And then next one. What is the SI unit of this? SI unit Newton per meter square into second or Pascal second. Okay, Newton per meter square into second or Pascal second. And in CGS system, you have its unit poise, and this is given by scientist name Poiseuille. Okay, and 1 Pascal second, the relation between CGS and SI unit is what? 1 Pascal second is equal to 10 poise. 1 Pascal second is equal to 10 poise. And its dimension formula, dimensional formula is 1 in mass minus 1 in length and minus 1 in time. Okay, got it. Clear? So let's stop here. I will upload this. You can write your own notes or whatever I have given. You can write the notes.